It looks like the way that most ancient civilizations approached math was, it was a very simple tool to use to figure out, as you said, commerce, construction, where, as you said, the Greeks, they brought math to a different level, where it was, they saw the transcendence of math.
Yeah.
It wasn't just a way to figure something out in the world. They saw math as the same level of philosophy and religion.
3, 2, 1. Welcome to Love Machine.
Welcome to another Nerding Out with That Nerdy Catholic. I'm here with my altar nerd, Cesar.
Hey,
and
my brother.
And today we are continuing our discussion on math. And the greater discussion, is math real? Last week we looked at Plato's cave and the question of what does it mean to be real? And today we're going to dive into at least we're going to start diving into the history of math. And it's going to be a kind of a broad, rough overview, right?
Yes.
But we're going to start at way back at the beginning. So why don't we start? Where did math start, Cesar?
I think it started when in the prehistory, when people start to count, to know how many sheep or how many things they have at hand. No, I remember when I was little, one of my history teachers told me that there were some cave paintings around, when you can see some numbers or sort of a numbers that are marked in the wall of this cave. This is way, way before, any great civilization. That's the need that the early men has for, for knowing how many things are there, that start driving math. And that's great, no? So even before we know something, the writing was invented, I would say, or what math was there. Math was there. The necessity of count, the necessity of start adding up things.
Yeah,
probably drive the first man to have math.
Yeah, and it's interesting to think about. We see the pictures on the cave walls, and we see the marks to see that they were saying, well, how many did we have? We don't know what language they had. There's a lot that we don't know about it. We don't know what they understood about addition and subtraction, but we at least knew that they needed to say, well, how many things do we have?
Exactly. So I think that's kind of the beginning, no? We besides those cave paintings, we don't have much more around that. But probably if we move on into the human history, we will see that the Sumerians has the first sexagesimal count system. No, they count from 0 up to 60, which is which is a lot. I mean, for the first 60 numbers, there is a lot, but there is a table, a Sumerian table that is dated 2,000 years, probably before Christ, 2,000 years or so. I don't remember exactly, but that is the first indication of a great civilization. Like the Sumerians having a document that they were, they were doing math.
Right.
Which is something great. We don't have that much documents from the past.
Right, and it's probably made by someone who was trying to figure out taxes.
That's probably true. How many do you have to pay to the king? Yeah. That's I completely agree with that.
You have to be able to count and add and subtract to see, or even multiply and divide to see. Well, this is how much you have. This is how much you owe the king.
Yes, definitely. That should probably be like that. And the other big force, it's the trade. You have to trade. Okay, I give you this something of these things. You gave me something these things. So that you need to count that. No,
Mhm.
so that's trade and probably taxes. I haven't thought about that. That could drive the beginning of the arithmetic. No, talking about that, there are kind of 4 pillars of math. No, we talk about arithmetic, geometry, trigonometry, and algebra. No, and I mentioned those 4 pillars in that way because I think they were started to use in that way. Arithmetic
in that order.
in that order.
Yeah.
Yes, exactly. Arithmetic has to do, as you well said, with adding, subtracting, multiplying, and that has to be the start. Definitely, that has to be the start. No? But then the fact that our ancient cultures start to build, great things. They need to know the shapes and the relationship between the measurements of the sides and and those shapes, and then bring us geometry.
Yeah.
And
Yeah. Thinking about if you're building a table, then you can take rough measurements.
Yep.
And you don't really have to. You don't have to do a lot of math, and it doesn't need to be exact or perfect. But if you're building a very large structure, you can't take a tape measure across one of the pyramids, right?
Exactly. That's something, you bring that to the table because I think that's the born of trigonometry. When using shapes, you need to calculate a bigger side that you cannot, as you said, have a tape to measure that. And that has to brought with angles and triangles, and that's exactly what trigonometry deals with. So and at the end, algebra, the abstraction of not having a number but a variable that replaces a number, that level of abstraction have to come at the end. I think, no.
Yeah.
And that's when, for example, moving from Sumerians to Egypt, we have the Rin papyrus. No, that papyrus is dated 1600 before Christ. So that means it's, first of all, it's really old. But the interesting thing is that in this papyrus, it is found arithmetic, but also geometry, trigonometry, especially as you mentioned, for construction of pyramids. We know that Cheops, Khephren, and Miserino were the 3 big, but Egyptians built pyramids all across the Nile, all across the territory. Those happen to be just the 3 bigs and the most impressive that we saw, but they started long before. So that indication, 1600. Imagine 1600 before Christ.
Wow.
It's a lot. It's a lot of time.
Yeah. Well, and I think it's interesting to think about. Think back to when I was taking math classes, and so when you're learning math in school, you don't learn about the history of math. So you just see the system that is complicated and sometimes it's boring. But to think about where it came from and how long it took to, we're going to talk about this later, but develop or discover, but how long it took to start from a very simple counting to, okay, now we need to understand how to add things together, take things away, discover how to multiply and divide, to thinking, well, now we need to, 1, think about larger numbers, 2, think about, how do we measure shapes, how do we measure volume, all these things, all these parts of math that were slowly discovered over time.
Yes. And I want to also mention something that I think it's written also in the Bible when God gave the instructions to the king to build the first temple, right? It has the P number at that time mentioned. It's just mentioned at 3. It has to be, the circumference of that has to be 3 times the diameter of that. So it's, and it has to do a lot with the capacity of the people of how exact or how precise do I measure?
Mhm.
If it's just something rough, you can always use free.
Mhm.
But if you're drawing a big thing with something really thin, you have to start using the decimals.
Mhm.
But as long as the approximation makes good sense,
Mhm.
which in the example of the Bible it's assigned P to 3, and I'm sure the temple was really beautiful as it
Mhm.
says. But if the construction get bigger, you need more precision.
Mhm.
And that's one of the things that we are going to talk about that also
Mhm.
when we talk about the Greeks.
Mhm.
But all in all, as you said, math has to be there. As a civilization was evolving,
Yep.
math was evolving. And talking about the ancient Egypt, they already, so just to put it into perspective, the Rim Papyrus is dated 1600 before Christ.
Mhm.
And we are talking that approximately 1400 to 1500 before Christ, Exodus happened. I mean, the
Mhm.
Israelites came out
Mhm.
and from Egypt. So
Yep.
that was way before that happened, no?
Yeah.
That way before. And at that time, they already have algebra, geometry, trigonometry. So they
Mhm.
have all the tools, mathematical tools to build a
Mhm.
great civilization that they
Mhm.
were, which is something really, really impressive.
Yeah. Well, actually, thinking about then, that's an interesting overlap. That's an interesting connection. Thinking about the rough date of the Exodus and the date of the papyrus, to think. So just, I just had this picture then in my mind of an Egyptian architect standing there working on this papyrus, figuring out the dimensions of this pyramid, while the nation of Israel is over there building, taking the clay, the sand and the grass, and building the bricks.
Yes.
For
that construction.
That construction.
Yes, definitely. That's something to think about. That.
Yeah, and I mean, just thinking about that in terms of, we have these ancient histories, and we think about, the history of math. We think about the history of the Jewish people, but all histories overlap.
Yes,
it's one history. It's the history of the world.
Yes,
and it's very easy to think kind of in silos.
Yes,
and not think about how everything connects.
That's true, and that's important. And trade and commerce bring that together. All those civilizations. But one of the biggest mathematician of the ancient history has to be the Greeks. Definitely the Greeks. And the reason is that, although, Sumerians, Egyptians, and all other civilizations, they have math, they use math, they develop up to upon algebra there. One of the things that the Greeks did, and none of the other civilization did until that point, was to elevate math into a discipline, into a theoretical discipline. Give that a standard and start developing into a theoretical discipline. And that means that they, first of all, has to dedicate time to study that. And that means that discipline has a set of rules to build, like one brick over the other. And the last thing is that the Greeks brought to math is that, the concept of proof. So if this is true, ergo this other thing is true. And they build that discipline with that. I remember you mentioned once in one conversation about, the Greeks having something about intertwine their philosophy with math, right?
So it's interesting to think about other ancient civilizations and how they approached math, because as you said, it looks like, I mean, there's a lot that we don't know
Mm-hmm.
about how people lived back then, because we have just fragments of things we can look back and try and figure out what life was like. But it looks like the way that most ancient civilizations approached math was, it was a very simple tool to use to figure out, as you said, commerce,
Mm-hmm.
construction, where, as you said, the Greeks, they brought math to a different level, where it was, they saw the transcendence of math.
Yeah.
It wasn't just a way to figure something out in the world. They saw math as this, as you said, the same level of philosophy and religion, and I think that's where, as you said, the Greeks were the first to figure out this concept of experimentation and proof, and a way to abstract math to the point where we can say, well, if I can solve this here, then I know, if I know that this is true,
Mm-hmm.
then I can figure out that this is true, and this is true, and this is true,
Mm-hmm.
because they logically connect.
Yeah,
right?
that's a very good point. They saw the truth in math, and they saw that when they elevate that as a discipline, they saw that they can build that truth,
Mm-hmm.
and they can either use it, but they can also continue start building up,
Mm-hmm.
no, which is something that no other civilization
Yeah.
until that point did.
Yeah.
No.
Well, and also what that led to was that the Greeks did math for math's sake.
Yes.
The
exactly.
Greeks didn't, I mean, I'm sure the Greeks used math as a tool like
Yeah.
other ancient civilizations, but thinking about, calculating pi, the Greeks wanted to calculate pi as precisely as they could,
Mm-hmm.
so that they could calculate pi
Yeah.
as precisely as they could.
Yeah. Exactly.
It wasn't necessarily to solve some problem that they were working on at that moment. And one of the things that I remember learning about the Greeks and how they discovered different aspects of math when they discovered in working at division,
Mm-hmm.
when they discovered the idea of having fractions
Mm-hmm.
and ratios, comparing numbers to each other, they had this idea that, as you said, combining religion and math, they had this idea that if you could represent a number
Mm-hmm.
as a ratio or as a fraction,
Mm-hmm.
that there's some perfection in that.
Yeah.
And I can even think about that. You think about you're trying to solve a problem, whether in engineering or math or computer science, and that moment when you realize, oh, there's a very simple solution for this, and you just get that feeling like, oh, good, everything's right in the world. There's something good here if there's a simple solution to a problem you're working on. So I can just see the Greek mathematicians getting to that point. It's like, oh, here's this number. Oh, I can write it as a ratio.
Yeah.
Like that. And so there is this idea of a perfection of a number that could be represented as a ratio, and there is an imperfection if it couldn't be represented
Mm-hmm.
as a ratio. And we know now, the way we describe it, we would say, a number is rational
Mm-hmm.
or irrational.
Yes, exactly.
Irrational number is a number that if you try and, if it can't be described as exactly as a ratio.
Mm-hmm.
And if you try and write it out in decimal form, the decimal number just keeps going and going and going forever and ever.
Yes.
And so, and you can never see in either the decimal or the ratio form, you can never see the perfect number. And to see how that, I remember when I realized the connection between the words irrational and rational, between math and looking at the value of something. Oh, that's irrational. That doesn't make any sense.
No, and that's right. That's how they integrated philosophy, math, logic, with
Mhm.
their worldview,
Mhm.
right? With their religion,
Yeah.
which is something.
Well, and even connecting that back to what we were talking about last week about Plato's cave,
Hmm.
that you can see in both of those examples the Greek desire to understand the world.
Yes.
You know,
Yeah.
to understand in a more precise and perfect way than other civilizations had desired. That to say that there has to be some rational
Hmm.
connection between the world around us, between the world of the gods.
And not only trying to to understand the world, but to know the truth.
Mm-hmm.
No.
Yeah.
So those are two big things that the Greek pursue,
Yeah.
and in that pursuit they start to build, I would say, an empire of knowledge,
Mm-hmm.
right? That will probably, I know I'm getting ahead, but it will probably surpass the Romans by
Mm-hmm.
far, no?
Yeah.
But let's talk about a little more about the Greeks.
Yeah.
Let's have an example of Pythagoras, for example.
Mm-hmm.
No, he was born in the Greek island of Samos, and one of his great contributions, and I remember this because I was a little kid in school. The triangle, rectangle,
Mm-hmm.
and you have to figure it out. Okay, if this is a rectangle, and you have one of the sides measure A and the other side measures B, how long is going to be the hypotenuse? No,
Mm-hmm.
and he is the one that invented that.
Mm-hmm.
The relationship as the formula for that. No?
Mm-hmm.
A squared plus B squared is equals C squared, which is something that for sure makes them build so many things, beautiful
Mm-hmm.
templates with precision,
Mm-hmm.
because you start to see the four pillars of math combining there. No?
Mm-hmm. Mm-hmm.
But also, that formula still stand out up to this moment, right?
Yeah.
It's still stand out. And the funny part is that he doesn't do only the formula. He do the demonstration of why that formula is true, which is again,
Yeah.
to your point prior. No, they want to understand the world, but they also want to understand what is true.
Yeah.
And they start with basic propositions up to the point that to start demonstrating more complicated things. No, so I think, I mean, Pythagoras did a lot of more things, but that's the one that hides out. It's Pythagoras theorem
Right.
that you and I
Well,
and
yeah.
everybody learn.
And thinking about this system of measuring triangles, angles,
Mhm.
we use the exact formula today.
Yes. Yes.
This is something that was from over 2,000 years ago, and everyone that learns that
Yeah.
that exact formula.
And going to one of the lessons that we learn from Plato's cave, no, the world of the ideas and the world of the senses, no, that the world of the ideas survives the time,
Mm-hmm.
doesn't change,
Mm-hmm.
which we find in that formula. That formula survives the time. It's it's more than I would say 2,600 years old that will celebrate the birth of that formula.
Yeah.
but that's a lot, and that's because that's, if Plato was there, I would say that's part of the world of the ideas. No?
Yeah. Yeah.
And the other thing I would like to say, there's another Greek mathematician, is Theatunus, I think is the correct name. He have to do a lot of work about what you said, no, the numbers that are called irrational numbers.
Mm-hmm.
No, so the way that he tried to understand how does this generate, why are they different from the rational number, the
Mm-hmm.
fractions. No, so for example, when we introduce Pythagoras, we introduce the square root. No,
Mm-hmm.
and usually, if it's not 4, if it's not 16, if it's not 9,
Mhm.
that's going to be led to an irrational number. No?
Mhm. Mhm.
And you can do an approximation, but that's only an approximation. No?
Right.
And that, this Greek mathematician is not well known really,
Mhm.
but his work on irrational numbers survives until the moment. No?
Yeah, yeah. And thinking about as you were talking about before, the connection between math and truth. This desire, I see this desire in all these Greek mathematicians. There's no need, if you're just thinking about measuring things that you're building, to go to that precision.
Exactly.
Of 6, 7, 8, 9, 10 decimal places.
Yes.
But if you're thinking about the truth of it, the more precise you are, the better.
Yes. Yes. Exactly.
The more truth you discover.
Exactly. And talking about truth, I want to jump forward to Euclides. No? He, in my view, he's one of the greatest Greek mathematicians that has ever been. No? And the reason I say that is because Euclidean geometry has not been changed, has been the base of every geometry for more than 2,000 years. I mean, the notion of knowing Euclidean geometry was just born late 18th century, when one of the greatest mathematician Gauss started thinking about surfaces that were not necessarily flat. No? But up to that point, the only geometry that we know is the Euclidean geometry. And he started building his geometry with a dot and a line, and saying that in a plane surface, you have a dot and you have a line, and there is just one tangent and one only tangent to be built to that. And with that premises, he started building his geometry that survived and was the only geometry for more than 2,000 years.
Yeah. So thinking about Euclid and his geometry, you have people that are studying math, especially on the graduate level, that are studying directly from his book, from the original source. And I think about other areas of study. One of my personal areas of study that I've been doing a lot of learning in is fermentation. And there's a lot that we understand about fermentation that we didn't even understand 100 years ago, let alone 2,000 years ago. And we know that the Egyptians made beer, and we the art of fermentation goes back thousands of years. But the understanding of fermentation has grown so much, and we've known so much about it in the last 100 years that with the understanding of microbiology, and that if you're studying fermentation now, you're using texts that people didn't have 100 years ago, let alone 2,000 years ago. But to think that that Euclid wrote his book on geometry, and people are still using that over 2,000 years later. And to think that people are not just studying it as a historic text, but studying it as a modern text, because we still use his math. We still use the exact formulas that he came up with.
Unless you have, something real in kind of curved space, we're still going to use Euclidean geometry, right? So that is, again, the pursuit of truth, and the fact that he built his geometry from basic, it is called axiom, his basic principles that are understood to be true. So on over that, they build theorem over theorem over theorem until they have, a whole building of knowledge, in this case,
Yeah.
geometry that we have to thank to Euclides, no? And that was built in such a way that, as you said, is surviving 2,000 years from this moment, no? So let's move to our next Greek mathematician. In this case, is Archimedes, no? Archimedes was born in Syracuse, no? And by the time Archimedes was has grown up, Rome has started to rise, and it is said in the history books that Archimedes was in his town and was trying to help to defend Rome, no? And he built a lot of artifacts because he in use of math, he built a lot of artifacts to keep the mighty, powerful fleet of Rome outside of the city, no? And it was also up to the point that they were thinking, okay, the Syracuse we are not going to take. So one of the things that he started to do in order to defend his city was to start building concave mirrors, so that the light of the sun concentrate in those mirrors and start burning those ships, no? He also built great catapults in order to throw the big stones up to the ships, no? But the precision on the angles and how strong has to be, it all has to be calculated. Yeah. And Archimedes was a great mathematician that for sure he can do that, no? So when the Romans finally conquer and get into the city of Syracuse, the general was eager to know the man that has almost beaten him, no? So he said to a couple of soldiers, "Bring me that man." So when the couple of soldiers found Archimedes was in the middle of something, trying to discover again. And I can figure it out, Archimedes, no. How is this done? Trying to solve, trying to find truth, try to dig into the realm of math on trying to know it more. And then the soldiers came and say, "Hey, my general is asking for you." Say, wait a minute. I just need to finish it. And the soldiers just kill him. I mean, what? They don't know, but they kill one of the greatest mathematicians of Greek history.
I know I've been in that situation many times where you're in the middle of trying to figure something out and someone comes in and it's like, just 1 minute, just 1 minute.
Yes.
Yeah.
Yeah. But, to Archimedes, we were talking about pi. To Archimedes, we have to say that he was one of the ones interested in knowing what is the true value. And again, this word came again, no? The true value of pi. No? He starts saying that it was greater than 3 over 10 over 71, but less than 3 on 1/7. No? So he narrowed pi among these two numbers, which is probably a 4 or 5 digit precision of pi. I would say, no, but that's that calculation to be done. It's something really impressive. No? Really impressive.
Yeah, and as we were saying before, the real world application of pi, creating something that's a circle, at that time, you didn't need even that level of precision.
Yes.
But the desire I need to understand more of this.
Yes, yeah, and that's one of the things that I think a lot of things were lost when Rome came, and just with mighty power, but not getting that much into bringing to science. No, my history teacher used to say that Rome conquered Greece, but the Greeks intellectually conquered Rome. No, and they were such a great civilization than the Romans were in terms of knowledge. No?
Yeah. Well, as we're talking about thinking about scripture,
Mm-hmm.
what language was the New Testament written in?
Oh, yeah.
And in Greek, not in Latin, because it was, there was the Greeks were the intellectuals. You said the intellectual powerhouses of the day.
Yes, exactly, and that is if you are to be intellectual, you have to know Greek at that time.
Yeah. And one subject that we want to start talking about at some point in the future,
Mm-hmm.
we want to get more into philosophy. But thinking about the Greeks had such a great influence on the whole world at the time. I remember when I first discovered, looking at scripture, looking at the books of Proverbs and Wisdom.
Mm-hmm.
And Proverbs was written before the time of the Greeks, and Wisdom was written during the time of the Greeks. And you can see the book of Wisdom talks a lot about the cardinal virtues,
Mm-hmm.
which was discovered by the Greeks.
Yes.
And so even the worldview of the nation of Israel
Mm-hmm.
was impacted by the philosophy of the Greeks.
Yes, and that's some of the contribution that the Greeks gave to the world. Actually,
Yeah.
They gave to the Hebrews, but they also gave to the world.
Yeah.
This pursuit of logic, knowledge, and in the case of the cardinal virtues, I'm opening a parenthesis too. It's the pursuit of the moral, what is true,
Mm-hmm.
to be a moral man.
Yeah.
No?
Yeah. And thinking about students to this day read Homer.
Yeah.
We study a lot of the original Greek sources that as you said, they have influenced not just the world of that day,
Mm-hmm.
but even today. So much of the way we see the world is seen through Greek eyes.
And talking about the Greeks, I want to bring Apollonius to the conversation, because
Mm-hmm.
we may not know him. Apollonius, if I say Apollonius, I'm sure nobody knows who Apollonius is, but he is the one that bring the conics to the study of the conics, no? And we are talking about parabolas, ellipses, hyperbolas,
Mm-hmm.
and these are all things that we have to deal with when we are in school.
Mm-hmm.
The equation of the parabolas or the hyperbolas. No,
Mm-hmm.
So we studied that in the school, in math of the school, and we are talking about knowledge that Apollonius was written 200 years before Christ.
Mm-hmm.
No, and we still study today.
Mm-hmm.
In a school.
Yeah.
So, and that's great contribution, because when we think about science, parabolas is the figure that if you are throwing something from a high roof,
Mm-hmm.
that's the shape of what
Mm-hmm.
what the object is done.
Mm-hmm.
When it's a free fall and
Yeah.
has some velocity in the x horizontal velocity.
Yeah.
So when you study about ballistics or you study about throwing objects or rockets, you have to study parabolas.
Yeah. Yeah.
Right?
Yeah. Even thinking about studying, trying to calculate, orbital velocity.
Yes, exactly.
Or how to get to the moon, right?
There you go.
I'm sure Apollonius never thought that the math that he was working on would someday help people get to the moon.
Or put satellites in orbit.
Yeah.
Right?
Yeah.
So, yeah. And we are using, again, we are talking about a guy that lived 200 years before Christ.
Mm-hmm.
No? And we still use his work because that is true.
Mm-hmm.
Right? That doesn't change
Yeah.
in time.
Yeah.
It's not subject to corruption like we figured it out in the ideal world of
Mm-hmm.
coming from Plato. No?
Yeah.
And for me, I mean, there are several more examples from the Greeks that if we do an episode, we for sure is going to be 3 or 4 hours.
Yeah.
But that is something that they did,
Yeah.
and they all follow this method of trying to find the truth, trying to demonstrate why it's true, and bring it, abstract that science not only to a use case that we can see now, but to seek the knowledge just in order to seek truth.
Yeah. It's interesting to think about this period of history, and especially the Greeks, everything that they discovered about math. But I love to, sometimes I like to step back and look at all of human history and think about the history of the world as the life of a person. To think about the periods of time in human history. And I know this is very imprecise and not completely scientific, but think about that as far as the period of the life of a person. And so when I think about the time of the Greeks, I think about a kid in middle school, and they're learning and discovering so much about the world around them. Before then, they were just kind of in their own world, building little things, using blocks. Kind of think about the time of the Egyptians and Babylonians building their own little things. And you get to the period of the Greeks, and you start to see that there's a bigger world out there. And I need to understand this world. And it's a period of discovery of something greater than themselves.
Yeah.
And then as they grow up, they keep that the truth that they learned, and then they can start applying that in many different ways. And so we're at this point we're in the period of human history where we can take all the truth that was discovered by the Greeks, and we have found so many different ways to actually apply that. And we keep learning.
Yeah.
We keep discovering more truth, but we haven't replaced the truth. As we said, we haven't replaced the truth that we learned from the Greeks.
We are just discovering more inside what is math.
We're discovering either more levels of precision, as you said, discovering non-Euclidean geometry, discovering this way. Well, what if, everything we do as far as our everyday life, even as we said, putting things into orbit, going to the moon, measuring distances in space, all use Euclidean geometry.
Yeah.
We're discovering now things that we couldn't even imagine a few hundred years ago, of what is life like around a black hole, or even close to the sun. How do things orbit around other things? How do planets orbit around stars? We're discovering that there are places here and there in the universe where space isn't flat.
Yes.
And so we need a different form of math. But it's still related to Euclidean geometry. It's not non-Euclidean geometry because it's completely different. It's just called non-Euclidean geometry because the formulas aren't exactly the same. It's basically applying Euclidean geometry to a space that's not flat, right?
Yep. And applying Euclidean geometry, the way that Euclides built his geometry is the same way that they start building non-Euclidean geometry. No? And for example, one of the theorems of Euclidean geometry is that internal angles of a triangle it's 180 degrees, no? So in non-Euclidean geometry, one of the theorems is that the internal angles of a triangle is not equal to 180.
Right.
No?
If you have a curved spherical space,
Yes.
then it's greater. No, then it's less than 180.
Yes.
If you have the term a horseshoe,
Yes.
where it's curved one way in one direction and another way in another, then it's
You
greater
may
than 180 degrees.
Yes, exactly. Another basic theorem of Euclidean geometry is that from a point that is outside of a rectangle, you can have just one parallel, right? So in non-Euclidean geometry, it says because of the surface, you may have multiple, which is something that they start thinking about. Mathematicians start thinking, but I mean, late in the 18th century.
Yeah.
So, but that doesn't invalidate Euclidean geometry.
Exactly.
We still use Euclidean geometry, but for other cases, when we are not dealing with plane surfaces, then we use non-Euclidean geometry.
Yeah. Well, this is a great start to the look at the history of math. We're going to keep digging into the history of math because we've only come up to 2,000 years ago, and a lot has happened since then. But as we said multiple times, it's amazing to see that we still use all this stuff. So we're going to keep looking at the history of math, and I think that as we move forward, we'll delve deeper into this idea that we brought up last week with Plato, started to develop looking at the Greeks. This idea of, is math something that we created or something that we discovered, or maybe even a combination of both? But I think as we've seen, the views that the Greeks had of math was this view of transcendence, that math was part of something outside of the world. And I think that's a concept that we're going to continue to develop as we keep going deeper into the world of math and what it means for us, and how we can use math to see deeper truths. Right.
Definitely. And we in this review and quick review, I will say, from history of math, we stop with the Greeks for the moment, but there's much more coming. We have to analyze.
So if you have any thoughts, we'd love for you to share them in the comments. If there's any mistakes that we've made, point those out as well. We are always willing to learn more, to see our mistakes, right, and to learn from our mistakes. But share any thoughts that you have in the comments. Any questions you have, anything you want us to cover in the future, let us know in the comments down below. Please share this video with your friends, your family. Subscribe so that you can, and click the notification bell so that you can get notified whenever we put something new up. And we hope that you will be part of this conversation as well. So, Cesar, thank you again, sir.
Thank you for having me here.
Right. And we'll see you again next week.
See you then.
System shut down.